In this video, we're going to look at operations on signed fractions. Perform the indicated operations on the fractions and/or mixed numbers using your knowledge of signed numbers. So here we have three examples we're going to start with. Notice here we have a positive fraction minus a positive fraction. So our result is going to be negative. That's why it's in this signed fraction section. We'll see that in just a moment. Here we have a negative fraction plus a positive fraction, and a negative mixed number minus a positive mixed number. Now here's the good news. This may seem intimidating. We have fractions. Now we're going to put these signs. But what it boils down to is we're going to perform the same procedures and operations that we did on fractions that didn't give us negative results or didn't have negative numbers, but possibly along the way we're going to use what we learned about integers to perform some computations. So let's see how this is going to work. So first, 3/7 minus 2/3. Just think of this as any old fraction problem, and the first thing we need to do is find the least common denominator. So the denominators are 7 and 3. So since their greatest common factor is 1, we can take their product, divide by their greatest common factor, and their least common denominator is just going to be 21, their product. So now we want to rewrite these with the least common denominator of 21. So 3/7. We want to write that over 21. And I see that 21 divided by 7 is 3, so I multiply the numerator and the denominator by 3 to get 9/21. Now I will do the same thing for 2/3. I want 2/3 written as an equivalent fraction over 21. 21 divided by 3 is 7, so I'm going to multiply the numerator and denominator both by 7. And I get 14/21. Now I'm going to rewrite this original problem with the equivalent fractions, and we have 9/21 minus 14/21. Since the denominators are the same, I can now subtract the numerators, 9 minus 14, and keep the denominator. Now this is where the signed number, signed fraction part comes in. Remember, with subtraction the order matters, so 9 minus 14, if you start at 9 and take away 14, that is going to be -5. Not a +5, so notice our result ends up being negative or involving a negative number. Okay, we didn't know that at the beginning, and that was fine. We actually didn't even know it till this step. So we use the fact that 9 minus 14 is -5, but we didn't need to use any extra rules about signed fractions in particular. There's one thing that's important for you to note. Now notice this is a -5/21, and there's an equivalency that you should know. This is equivalent to 5/-21. So you could think, if you think of fractions as division, one of the ways to think of them, 5/21 is whatever quotient it is, and if we have a negative divided by a positive, the result is negative. So you could put the negative in the numerator or the denominator, but typically our final answer we write in a different way. We write with a negative sign out front and then 5/21. We try to center the negative kind of where the fraction bar is. I think this typed example is a better version. I put mine a little bit higher. But this is saying -5/21 as opposed to -5/21. And I realize they sound exactly the same, but notice the difference. This is thinking of a negative fraction. Okay, this is our final result. Let's look at the next one. So we have -2/5 plus 7/5. Okay, now notice they have the same denominator, so we don't need to find a common denominator. But notice I wrote the negative sign just a little bit higher, because since this is negative, just like we did here, we could think of the negative as belonging to the 2, the denominator the 5, or being out front. And I want to think of it as the 2 being negative. It needs to be somewhere, top, bottom, or in front. Because now, to perform this, since they have the same denominator, I'm just going to add the numerators, negative 2 plus 7, and keep the denominator. Well, negative 2 plus 7 is positive 5, and 5 over 5 is 1. Okay. So again, the way we use negative numbers in this problem is we had a negative fraction. We thought of the 2, the negative sign as belonging to the 2, so that we can add the numerators and keep the common denominator of 5. Now we have one more. Okay. So here we have a negative mixed number, and then we're subtracting a positive mixed number. And what we're going to do is start by rewriting these as improper fractions like we did before. Now notice this negative mixed number. This is negative 2 2/5. So on the number line you could think of going to the left 2 whole units and another 2/5 of a unit. Now, in terms of this mixed number, before we change it to an improper fraction, we're going to think of the 2 and 2/5, because remember there's implied addition with a mixed number. We want the opposite of 2 and 2/5. So we're going to find the improper fraction for 2 and 2/5 and keep the negative on the outside or out front. So 5 times 2 is 12. 12 plus 2 is 14. So this is negative 14/5. Okay, so just notice I didn't say 5 times negative 2 is negative 10 plus 2. We're keeping this negative sign out front. Now we'll write the subtraction. 5 times 4 is 20, plus 3 is 23. Okay. Now we have the same denominator. That saves us some work, so we have subtraction, so subtract the numerators, keep the denominator. And again, like we did here, I'm going to think of the negative with the 14. I don't want to put the negative down here, then the denominators aren't the same, and it causes problems later. So we'll have negative 14 minus 23 over 5. We'll think if we start at 0, we go to negative 14, and then we take away or move to the left 23. That's negative 37 over 5. Okay. And now, again, as an improper fraction, we write the negative out front. So here we had a numerator that was negative, but we think of this as a negative fraction as our result. This improper fraction is completely simplified, but I'm going to write this as a mixed number. And as a mixed number, 5 goes into 37 7 times, with the remainder of 2. So 37/5 is 7 2/5. And since it was negative, we have negative 7 2/5.